You might have heard that using system calls is very costly and you should avoid it, especially if you have loops. And today I'm going to demonstrate why exactly that is the case in a direct C benchmarking program. So I've created it already and I'm just going to go through it very quickly. So starting from the main function, what it does basically is we're going to call a basically a function that does nothing, or a no operation function, and measure the time it takes in nanoseconds. So this function here is defined. It does nothing, it just returns a value and that's it. And we're going to run it for n amount of times, where n is defined as to be 1 million in this case. And we're going to just print the time it takes in nanoseconds for each function call. And here we have another, very bad, okay. So we have another function called a million times, which basically calls getPID. And getPID internally uses a system call to get the process number or the process ID. And again, we just print out the time it takes per call in nanoseconds. Anyways, I'm gonna compile this. Now, after compilation, I'm just gonna run it very quickly. So you can see already the significant difference between a normal function call and a system call or a syscall, right? It's almost 3 times a normal function call. Sorry, 300 times. You can already see it's like the massive difference between these two, and why you should try and avoid or be very careful about system calls within your programs. Anyways, I'm gonna use strace to basically trace the system calls just to confirm one thing, and that is that we do actually call it a million times. And it will take a longer time, so I'm just going to skip ahead. Now, the first thing after seeing the results is that you have a massive overhead, right? And that's just because strace, profiles things for every single function call, which just increases the time it takes. But that's not the worry here. The main thing we wanted to see is that, in fact, getPID does get called 1 million times in the program. The next thing I'm going to use is the profiler tool. So perf stat. Okay, I need to run it in sudo mode. We still have some overhead, though it's much less. But the more important thing I want to show and demonstrate is that out of all the time elapsed within the program, right, almost half of it, or actually more than the user space, right, we're spending time in the kernel space, and is directly a consequence of using a syscall through getPID. And just to again show it even further, let me just comment this out and let's compile again and let's run this again. This time, right, we basically don't have the system calls and the program takes a much less amount of time. So all in all, you could see why syscalls are very dangerous, or they can hurt your program's performance if you don't use them right. And also, it is a reason that in modern Linux there are newer mechanisms or architectures to do such actions when you need a privilege operation or you need access to the kernel space, and you have tools like the IOUring or eBPF and many other things to use. Basically you're encouraged to use those if you need syscalls or anything within the kernel space. And hopefully I will cover some of those things in later videos and just get deep into those concepts like eBPF and how you use them and what they do exactly differently that is better. So I hope you enjoyed this video and you got to see some kernel level stuff in action. I'll see you around in the next video.